Okay, hello all. This is the answers to Orange Workbook, page 123. Hope all is well with you and you're doing your homework, you're keeping up with the work, you're not procrastinating, and you complete the work as it is assigned. So we're going to start with question number 13. And it says which compound solubility decreases most rapidly as the temperature changes from 10 to 70 degrees Celsius. So let's see, what happens to the temperature? Temperature goes from 10 to 70, so temperature increases. So when the temperature increases, we want the solubility to decrease. We have to go to our reference table, table G, and let me just decrease it, okay? So there's our reference table G. So when we go to our reference table G, we see that as the temperature increases, we have some curves where the solubility, the amount of salt that dissolves increases. However, we do have 3 of them where the solubility decreases, and we talked about it, and you should have written over here to the right over here that those have to be gases. So we see that it's this one, and I cannot draw. It's the SO2, NH3SO2, and then the third one is the HCl, hydrogen chloride. So those are the only 3 that as the temperature increases, the solubility decreases, and all 3 are gases. So for all gases, as the temperature increases, the solubility decreases. So let's go back to our question. And for which compound will the solubility decrease? Well, it's going to be NH3. If you're going, and HCl. So we're going to see that those are the 2 that as the temperature changes from 10 to 70, the solubility decreases. Now it says which compound solubility decreases most rapidly. So let's go back. NH3 and HCl. So from 10 to 70, let me just draw this. So we have from 10 to 70. Okay. So, and we have, here is the HCl, and here is the NH3. So let's see. For HCl, at 10 degrees Celsius, it is approximately, I don't know, 77 grams. And at 70 degrees Celsius, the HCl is approximately 52. So 77 minus 52, we get an answer of it decreased by 25 gram decrease. Let's go now for NH3. At 10 degrees Celsius and at 70 degrees Celsius. At 10 degrees Celsius, we're going to see NH3 to have 70 grams. And at 70, we're going to see that it has around 18 grams. So 70 minus 18, we get 52 gram decrease. Therefore, it's going to be NH3, the answer. And when we go back over here, going to write that the greatest decrease is going to happen at NH3. Will HCl decrease? Yes, but it doesn't decrease most rapidly. All righty, let's move on to the next question, number 14. Let me just make it a little so that we can see everything, all the choices. When we go here, it says solubility for salt X is shown in the table below. Which graph most closely represents the data shown in the table? So let's see what's over here. On the x-axis, we have temperature, 10, 20, 30, 40, 50, 60. So it goes up by 10. And then we have the solubility that as the temperature increases, the solubility increases, 5, 9, 13, 18, 27, and 35. And based on that, I can eliminate choice 1 and choice 3. Because as the temperature increases, the solubility increases, so my curve should have a positive slope. So therefore, it's not going to be 1 and 3, because as the temperature increases, the solubility decreases. So it's going to be between 3 and 4. Here we see that it's consistent. As the temperature increases by 10, there is an increase. And because it's constant, there's no change, the increase in solubility should be constant. It should be up by 4, it should be up by 5 or 10. So when what are we going to see over here? We're going to see that from 5 to 9, it increased by 4. 9 to 13, it increased by 4 again. And then 13 to 18, it went up by 5. 18 to 17, it went up by 9. And 27 to 35, it went up by 8. So we're going to see that it doesn't increase, it's not consistent. It's an increase, slow increase in the very, very beginning. And then what we see, it's a rapid increase. So therefore, that's not it, but it's this one. Let's go to question number 15. A solution contains 14 grams of KCl in 100 grams of water at 40 degrees Celsius. What is the minimum amount of KCl that must be added to make this a saturated solution? So let's find KCl and find out at 40 degrees Celsius, how many grams do I have to have dissolved in 100 grams of water to have a saturated solution? For a saturated solution, I have to go on the plot. So let's go over here. So if I go at 40 degrees Celsius and 40 degrees Celsius and KCl. So 40 degrees Celsius and KCl, and here is the plot for KCl. Here we go, there is KCl. Okay, so we're going to see if we go across. Now let's go across. We're going to see that approximately, I don't know, 39 grams of KCl need to dissolve in 100 grams of water. Okay. How many, let's go back to the question. Okay, so let me just erase 39. So we need 39 grams of KCl in 100 grams of water. How many do I already have in there? Well, I have 14. I need 35. I already have 14. I'm sorry, I need 39. I already have 14. I need 25 grams more. I already have 14. I'm going to add 25 to make it a total of 39 grams to make it a saturated solution. After being number 16, After being thoroughly stirred at 10 degrees Celsius, which substance will produce a heterogeneous mixture with 100 grams of water? Heterogeneous mixture means that I have two phases. I have aqueous, water with something dissolved, and I have something extra that it's a solid over here. So what does that mean? That means that I had more salt that it can dissolve. So I'm going to have a saturated solution. It's going to dissolve, the water is going to dissolve whatever it can to form a saturated solution at this temperature. And any extra that it cannot dissolve, it's going to fall on the bottom as a solid. So let's go to our reference table and find at 10 degrees Celsius, how many grams of each salt do I need to have a saturated solution? So we need KNO3, KCl, NaCl, and NaNO3. So let's go to our reference table. So we're going to go to 10 degrees Celsius. And we're going to look at these graphs. We're going to look first at KNO3. Actually, and if we draw it, KNO3 and 10, it's over here. So I'm going to write over here, that's my KNO3, and I'm going to say that I need approximately 24 grams of KNO3 to make a saturated solution at 100 grams. Then the next one is KCl. Let's choose a different color. So KCl, our KCl is over here. At 10 degrees Celsius, I need it to be over here. So I'm going to say 30 grams of KCl. Let's pick a different color. Let's go with the green. The next one is NaCl. NaCl is right over here. I'm going to go across. Can I draw? Okay. So let's go where it's at 10 degrees Celsius. It's over here. And I'm going to say it's going to dissolve 37 grams of NaCl. And the final one is NaNO3. And NaNO3 is over here. So when I draw that, okay, I'm going to say approximately 80 grams. Okay, let's go to our question. Maybe I should write them. Okay, over here. So for KNO3, in order for me to have a saturated solution, what do I say? For KNO3, I need 24 grams, right? 24 grams. Let me just go back. See, that's, yeah, 24 grams. Okay. So let's go back over here and let's write 24 grams of KNO3. Let's write it here, 24 grams. KCl, we need 30 grams. It can dissolve. NaCl, it can dissolve 37 grams. And NaNO3, it can dissolve 80 grams. Let's erase now. Okay. So let's see. Even if you have no idea, you're going to see that 30 is above 25, 37 is above 25, and 80 is above 25. You cannot have three right answers, so this is going to be the answer. But now let's explain why. If you have 100 grams of water, in order for you to have a saturated solution, you need 25 grams to dissolve. You have only 24. Okay? You need 24 grams to make it a saturated solution. So what does that mean? 24 grams will dissolve. And the 1 gram is not going to be able to dissolve, and it's going to fall on the bottom for KNO3. For KCl, it can dissolve 30. If you have 25, it can dissolve 5 more grams of KCl. For NaCl, it's going to be able to dissolve and form a saturated solution if you dissolve 37. You only have 25 grams. You can dissolve 12 more grams. Same thing over here. So therefore, the answer, when are you going to have a heterogeneous mixture, is choice 1. It's a little more conceptual and can be a little tricky, this one. Let's move on to question number 17. Which of the following substances is least soluble in 100 grams of water at 50 degrees Celsius? So let's write them over here. So we're going to have NaCl, KCl, NH4Cl, and HCl. And they're looking for the least soluble at 50 degrees Celsius. Okay. We're going to go at what temperature did they say? They said at 50 degrees Celsius. So we're going to go here. Okay. And we are going to see that NaCl is right here. KCl is right over here. NH4Cl is right over here. And HCl is this one. So which one dissolves the least amount of salt? Which one is the least soluble? Which one is the lowest on the graph? We're going to see that it's NaCl. Therefore, the answer is going to be NaCl. Okay. Now I cannot erase this. So let's see, I don't know. Okay. Let's move on. Number 18. A student obtained the following data in a chemistry laboratory. So we see trial 1, at 25 degrees Celsius, he was able to dissolve 40 grams. At trial 2, at 32 degrees Celsius, he was able to dissolve 50 grams of KNO3 at 100 grams of water. Trial 3, 43 degrees Celsius, he was able to dissolve 70 grams of KNO3 at 100 grams of water. And trial 4, at 48, he was only able to dissolve 60 grams of KNO3. Based on the reference tables, which of the 4 trials seems to be in error? So let's look at KNO3. If we look at KNO3, as the temperature increases, the solubility increases. And it's consistent. It's a constant increase. If we go back to the table, we're going to see that it increases from 40 as the temperature increases, the solubility increases, but then at 48 we see a drop. So therefore, which one seems to be in error? It's going to be choice 4. Choice 4, because it should be higher than 70 based on the graph trend. If you want, you can go and find at 48 degrees Celsius, what should it be? So let's see, at 48 degrees Celsius, what should the solubility be for KNO3 at 40 degrees Celsius? So 48 actually, sorry, 48, and we're looking at KNO3, and we're going to see that it should be 84, not 60. Therefore, the answer is 4. It shouldn't be 60, it should be close to 80. Number 19, how many grams of the compound potassium chloride must be dissolved in 200 grams of water to make a saturated solution at 60 degrees Celsius? So again, we're going to go to KCl. Let's draw this. Let's find the curve for KCl. There's my curve. Then we're going to go to our temperature, which is 60 degrees Celsius. Oh, let me just do it better. And I'm going to go across, and I'm going to see that it's going to be approximately what? 39 grams of, I'm sorry, see, I made the mistake. Why did I go over here? Why did I stop? Don't make my mistake. I didn't go on KCl. Where did I go? NaCl. So that can be a little tricky. So you have to be careful because you can get, so I'm going to go here and I'm going to go across, and I will see that it's approximately 45 grams can dissolve. Let me just erase the other one. Okay. So 45 grams of KCl can dissolve in 100 grams of water, but I don't have 100, I have 200 grams. So what do? I multiply by 2. Therefore, I multiply 45 by 2 and I'll get 90. Grams. Let's go to table F. According to table F, which ions combine to form an insoluble compound with a chloride ion? So let's go to our reference table F. What you should have on this reference table is this. You should have circled soluble. The exceptions make them insoluble. You should have insoluble. The exceptions make it soluble. So they're looking at the chlorides. So all of these are soluble, but these exceptions make them insoluble. Based on the choices, what do I have? Well, the choices that I had was Fe plus 2, Ca plus 2, Ag plus, and Li plus. So out of them all, I don't see Fe plus 2 over here. I don't see Ca. I do see silver Ag plus, and I don't see this. So therefore, the answer is silver ion. Which ion combines with barium plus 2 to form a compound that is most soluble in water? So let's go find, and we have the choices, right? Let's go find barium. Let's look at the choices. Sulfides are over here. And we want it to be what? Most soluble. So we want it to be either here or here. So sulfides, Ba. Let's go over here. is BA plus, is BA plus 2 soluble? Well, sulfides are insoluble unless you have a group 1 or ammonium. Well, barium is plus 2, therefore it's going to be insoluble. The next choice is the hydroxide. Hydroxides are mostly soluble unless they combine with barium plus 2 that makes them soluble. So we're going to say hydroxide should be the answer, but let's check the other choices. We have carbonate. Carbonates are over here, so they're going to be insoluble unless you have a group 1 or ammonium. What did we say barium is? Barium is a group 2. Therefore, it's going to be insoluble. And finally, sulfates. Sulfates are over here. They're soluble, but we see barium makes it insoluble. Therefore, the answer is hydroxide. Let's clear our drawings. Let's go back. And we're going to say that the answer is hydroxide. Finally, 2 more questions. 22. 1 gram sample of a compound is added to 100 grams of water, and the resultant mixture is stirred thoroughly. Some of the compound is then separated from the mixture by filtration. Based on table F, the compound could be. So in order for it to be separated by filtration, you have to have a solid forming. In order for a solid to form, you have to have this compound is going to be insoluble. So out of all those choices, AgCl, CaCl2, NaCl, and InICl2, which one is insoluble? Where are we going to go? We're going to go to our reference tables. So AgCl, there is my Cl, there is my Ag. Therefore, it's going to be AgCl is going to be insoluble. CaCl2, there is my Cl, but Ca is not here. Therefore, it's going to be soluble. NaCl, Cl is here. Na is not over here, it's over here, so it's soluble. Here's your chloride. Nickel is not here, therefore it's soluble. Even if you weren't sure that you were looking for an insoluble, if you look at your reference table and you see that you have 1 insoluble and 3 soluble, you can only have 1 correct answer. And that's what I'm saying. You have to use your test-taking techniques. So therefore the answer is, we're going to clear all drawings, we're going to go back, and we're going to say that the answer is AgCl. Finally, which amount of a compound dissolved in 100 grams of water at a stated temperature represents a solution that is saturated? That means that it's on the curve, and you are going to find all these points, the temperature and the grams, and see what's going on. So let's go to our reference table. We're going to go to our reference table G. I'm going to minimize a little bit. Okay, so the first choice is 80 degrees Celsius, 80 degrees Celsius, KClO3, 80 degrees Celsius, and 20 grams. So we have this point. For KClO3, where's KClO3? KClO3 is right over here. So we're going to see if I only have 20 grams of KClO3 at 80 degrees Celsius in 100 grams of water, this one, choice 1, is going to be unsaturated. because in order to be saturated, I need approximately 44 grams of KClO3. Let's look at choice 2. 40 grams at 25 degrees Celsius, 25 degrees Celsius, and 40 grams, 25 and 40. It's right over here. Here's my 40. And what graph am I looking for? I am looking for KNO3. Where's my KNO3? My KNO3 is over here. And I'm going to see that this point right there. So this point is on the graph. If it's on the graph, therefore it's going to be saturated. Let's go at choice 3. 60 degrees Celsius and 40 grams. 60 and 40. It's right over here. In relation to what graph are we talking about? KCl. Where's KCl? KCl is over here. Whoops. I cannot draw on my eye. Therefore, this one is, if it's below, it's unsaturated. And choice 4, let me use a different color. Let's go with the blue. 40 degrees Celsius and 60 grams. So 40 and 60. So over here. This point is right over here. And we're talking about NaNO3. Where is NaNO3? NaNO3 is right here. So we're going to see, look at the graph, it's below, therefore it is unsaturated. And the answer, finally, we can see that it is choice 2. Let me just be able to write. Choice 2, 40 grams at 25 degrees Celsius. Thank you for your patience. Thank you for working out the problems. Write down the answers and show me your work.